Previous class we have discussed about only heat engine. So what is heat engine? Which convert heat into work is heat engine. Now we are talking about Carnot heat engine. Is a scientist Carnot. Actually it is a most efficient engine in the universe. So actually it is a imaginary engine. That means there is no such engine which is having 100% efficiency. So it is a imaginary engine and it is a hypothetical engine. So hypothetical means it cannot exist ప్రాక్టికల్గా ఇదేం ఎగ్జిస్ట్ అవ్వట్లేదు, జస్ట్ యాజ్ ఇమాజినరీలో వీ కెన్ సే ఇట్ ఈస్ ఎ 100% ఎఫిషియంట్ ఇంజన్ అండ్ ఆల్ ద ప్రాసెస్ ఇన్ ఇంజన్ అక్కర్ ఆర్ రివర్సబుల్. సో ఆల్ ద ప్రాసెస్ ఆర్ రివర్సబుల్. లెట్స్ సీ efficiency maximum of any such engine which takes between same two temperature T1 and T2. Okay, it consists of 4 cyclic process. This Carnot heat engine consists of 4 cyclic process: isothermal reversible expansion, adiabatic reversible expansion, isothermal reversible compression, adiabatic reversible compression. All these 4 process occur in Carnot heat engine. Let's see, we know the temperature, we know the curve, that is PV curve. We are taking pressure on y-axis and V on x-axis. So we are having 4 process: isothermal expansion, adiabatic expansion, isothermal compression and adiabatic compression. Let's see one by one. So here we know that efficiency neta is equal to 1 minus q2 by q1, that is equal to 1 minus t2 by t1. It is proved by Carnot. So Carnot cycle will prove this equation. Let's see one by one. See here we have a working substance. So we have a working substance here. It is our working substance. We are taking in a pure ideal gas. We are taking pure ideal gas. There is no actually pure ideal gas. See, it is a hypothetical. We are saying it is a hypothetical. That means it is occurring only imaginary. It is not existing. So we are taking pure ideal gas in perfectly conducting substance. So if the base is the perfectly conducting and these sides are insulating. Insulating means they do not allow heat. Conducting means it 100% allow heat. 100% allow heat or current. So it is our working substance. It has a frictionless piston. It is our frictionless piston. So what we are taking here, working substance, it has pure ideal gas. It is perfectly conducting. Base is perfectly conducting. It is a frictionless piston. Next, what is our next topic is source, which gives heat. It is our source. It is perfectly conducting and it has having infinite heat capacity. That means if it gives some heat to the it working substance, heat energy is not decreasing. That means it is infinite heat capacity. దీని దగ్గర హీట్ కెపాసిటీ చాలా ఉంది. కొంత అమౌంట్ ఆఫ్ హీట్ ఎనర్జీ బయటకి ఇచ్చినా దాంట్లో ఎలాంటి చేంజ్ రావట్లేదు. నెక్స్ట్ సింక్ అంటే ఎక్కడైతే హీట్ ఎనర్జీ వెళ్ళి రిలీజ్ అవుతుందో ఆ రిజెక్ట్ అవుతుందో దాన్ని ఏమంటున్నాం, వీఆర్ టెల్లింగ్ ఇట్ యాజ్ ఎ సింక్. ఇట్స్ టెంపరేచర్ ఈజ్ T2. It is also perfectly conducting. It is also perfectly conducting. Next we have stand here. Stand is a perfectly insulating. See, one by one step చూడండి. మీకు బుక్లో యాస్టిస్ ఇస్ లేకపోయినా ఇఫ్ యూ గెట్ ద కాన్సెప్ట్ హియర్ వీ కెన్ అప్లై టు అవర్ బుకిష్ లాంగ్వేజ్. So it is perfectly insulating. It is stand. So what we are having here, we have 4 substances. First one is the working substance, next one is the source, next one is the sink, next one is the stand. What we are doing here, this is the first step 1. In step 1 em chestunam, we are bringing this working substance into our source. We are contacting this working substance into source. We have ideal gas in this working substance. Okay, next these are the small weights on the piston. We have small weights on the piston. If you remove these weights, small weights ni if you remove slowly, what happen, the piston move upward. Okay, the piston move upward and it is a source is a temperature T1. So expand, gas ఏమవుతుంది, expand అవుతుంది. When piston moves upward, gas will go outside. That means gas is undergoing expansion. Next here, this is the T1 is the temperature. Automatically what happened, this gas take heat energy from the source. So heat energy ఏం చేస్తుంది, heat ఏం చేస్తుంది అని అంటే source it will give heat energy to this ideal gas. That means here gas is undergoing expansion. Next it is a heat is kept constant, that is isothermal expansion. We can say it is a isothermal expansion. See here we have a point here. At point pressure is P1, volume is V1, temperature is T1. Next gas is undergoing expansion. That means pressure changes, volume changes, P2 and V2. But we are telling it is isothermal. Isothermal means temperature is constant. That's why it is T1, and here also temperature is T1. P1, V1, T1. When isothermal expansion జరిగింది, గ్యాస్ పైకి వచ్చిందంటే ఎక్స్పాండ్ అయ్యింది. సో P2, V2 and T2. సో T1. Next, step 2. ది సేమ్ వర్కింగ్ సబ్స్టెన్స్ని వీఆర్ కాంటాక్టింగ్ విత్ స్టాండ్తో కాంటాక్ట్ చేస్తున్నాం. స్టాండ్ ఈజ్ పర్ఫెక్ట్లీ ఇన్సులేటింగ్. దట్ మీన్స్ ఇట్ డు నాట్ ఎలో హీట్ ఎనర్జీ. అగైన్ స్టిల్ ఇప్పుడు ఏం చేస్తున్నాము, స్లోలీ రిమూవింగ్ వెయిట్స్. స్టిల్ వీఆర్ రిమూవింగ్ ద వెయిట్స్ ఫ్రమ్ దిస్ వర్కింగ్ సబ్స్టెన్స్. ఇక్కడ నుంచి వెయిట్స్ని తీసేస్తున్నాం. సో ఈవెన్ దో ఇట్ ఈస్ ఎక్స్పాన్షన్ ఓన్లీ, వెయిట్ని తీస్తున్నాం అంటే ఎక్స్పాండ్ అనే, బట్ ఇక్కడ ఇన్సులేటింగ్ అంటే హీట్ ఎనర్జీ నాట్ అబ్జర్వింగ్ ఫ్రమ్ దిస్ స్టాండ్. దట్స్ వై ఇట్ ఈస్ అడియాబాటిక్ expansion. So here pressure changes to P3 and volume changes to V3, and temperature is also changes, so T1 to T2. So it is also adiabatic expansion. Next, gas expand till it reaches to T2. Temperature T2 వచ్చేంత వరకు కూడా gas expand అవుతూనే ఉంటుంది. Next, step 3, when we close contacting this working substance into sink. So sink is we are adding weights. Now we are adding weights. ఇందాక ఏం చేసాం, we are removing weights, but now we are adding weights slowly. So here it is a heat release అవుతుంది. Heat is releasing, that is isothermal. Next, here when we adding weights means gas gets compressed. So compress అవుతుంది. We are adding weights. Weights add చేస్తున్నప్పుడు ఏమవుతుంది, gas molecule will come closer. Next, it is undergoing compression. We can say it is isothermal compression. Next, in step 4, again this working substance is in contact with the stand. So what happened, it is perfectly insulating. There is no change in heat energy. So adiabatic. Change in heat energy లేదు, zero అంటే that is adiabatic. Again we are adding weights very fastly, so gas molecule will come close, that is compression. We can say it is a adiabatic compression. So we have isothermal expansion, next adiabatic expansion, next isothermal compression and adiabatic compression. Here only heat energy either loss or gain occur in 2 steps only. In isothermal expansion, it is we are giving energy, that is absorbing energy. In isothermal compression, energy is releasing, that is Q2. Here it is Q1 and it is Q2. Let's see the mathematical expression for this process. Say for example, these are the points, A point, B point, C and D. We have AB process, BC process, CD process and AD process. Let's see one by one. So first one is a isothermal reversible expansion. So AB process is the isothermal reversible expansion. So we know that isothermal means delta T is equal to 0. So when temperature change in 0, then internal energy change is also 0. Q is equal to W plus delta U. That is our first law of thermodynamics. In this, delta U is 0. What happened? Heat energy is equal to work done. In a isothermal expansion, what is the equation for work done? That is nRT log V2 by V1. That is nothing but our Q1. Here T1 is the temperature. BC process. BC is the adiabatic expansion. In adiabatic expansion, Q is 0. We have already equation, that is nR T2 minus T1 1 by gamma. So we can say it is a delta U1. It is a delta U1 and it is delta U2. So CD process. In CD process, isothermal compression. Again isothermal means temperature is constant, 0. So we can say delta E is also 0. Again W3 is nR T2 log V4 by V3. Again adiabatic compression. So in this, if you want net work done, W1 plus W2 plus W3 plus W4, we know that W2 and W4 will get cancelled. We got W1 plus W3. So what is W1 here? W1 is nothing but nR T1 log exponent V2 by V1 plus nR T2 log exponent V4 by V3. So we know that neta efficiency is equal to, so that is work done Q2 minus Q1 by Q1. So Q1 minus Q2 by Q1. So that is Q1 is nothing but W1, next to W2, next to W1. All will get cancelled, 1 plus. So here we have T2 by T1 log V4 by V3 and log V2 by V1. And we know that from this expression we got, that is 1 minus T2 by T1. This is hence our Carnot cycle proved that neta is equal to 1 minus Q2 by Q1, that is equal to 1 minus T2 by T1. This is our about our Carnot cycle.